In the last video, we have seen that x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is a general equation of a circle, and any circle can be written in this form. This is a general equation of a circle. Now let us try to find out the equation of a circle which is described on a diameter on a line as its diameter joining 2 points. We are trying to find out a circle with line joining the points x1 comma y1 and x2 comma y2 as a diameter, as its diameter. So what we are trying to find out is, see, this is your circle and you are given one diameter endpoints of a diameter of the circle. This is point x1 y1 and this is point x2 y2. This is point q, this is point p, this endpoint is p, this endpoint is q, and you need to find out the equation of this circle. So let us try to find out the equation of the circle. So what exactly you need is, you need to find out the locus of a general point on the circle. Suppose this is any point a, h comma k. This is any point on the circle and I want to find out the equation, the locus of this point. So what we will do is join these two, this p and a and this q and a, right? Now the first thing you should notice that we know that angle in a semicircle is a right angle. So this angle PAQ is a right angle. Since angle in a circle, angle in a semicircle is a right angle, therefore angle PAQ is equal to 90 degree. It means that this line PA, it implies that PA is perpendicular to AQ. This line PA is perpendicular to this line AQ. So now what is the slope of this PA? Slope of PA is y2 minus y1. This basically, if you are given two lines, a1, 2 points, endpoints of a line, a1 b1, a2 b2, then the slope is b2 minus b1 upon a2 minus a1. Therefore here the slope of PA is k minus y1 h minus x1. K minus y1 h minus x1. Similarly, slope of AQ is k minus y2 upon h minus x2. Now since PA is perpendicular to AQ, therefore slope of PA times slope of AQ is minus 1. Suppose this is m1, this is m2. Slope of PA is m1 and slope of AQ is m2. Then PA perpendicular to AQ implies m1 times m2 is minus 1. This is a result which states that if two lines are perpendicular, then the product of their slopes is equal to minus 1, which implies that k minus y1 upon h minus x1 times k minus y2 upon h minus x2 is equal to minus 1, which says k minus y1 times k minus y2 is equal to minus h minus x1 h minus x2, which means k minus y1 k minus y2 plus h minus x1 h minus x2 is equal to 0. I can replace this hk with x comma y, that is a general point on the circle. So the equation of the circle is, therefore the required equation of the circle is y minus y1 y minus y2 plus x minus x1 x minus x2 is equal to 0. This is the equation of the circle with x1 comma y1 and x2 comma y2 as the endpoints of its diameter. Okay. Now, for example, you need to find out a circle whose endpoints of the diameter are 1 comma 2 and 4 comma minus 3. Then you can simply write the circle as y minus 2 y minus minus 3 plus x minus 1 x minus 4 is equal to 0. This is the equation of the circle with 1 comma 2 and 4 comma minus 3 as the endpoints of its diameter. Okay, next let us try to see what are the intercepts made by a circle on the axis. You have some circle and you want to find out the intercepts made by a circle on axis. We'll start with general equation of the circle. You have this circle ax square plus ay square. We have already seen that a second degree equation will represent a circle if and only if the coefficients of the x square term and y square term are same and the coefficient of the term containing xy is absent. So I can write the equation of a circle as this. Simply what I did is I multiplied x square with a and y square with a. Accordingly your g and f will change. You can also write this equation as x square plus y square plus 2gx plus 2fy plus c is equal to 0. That will not make any difference. The only thing is this is a specifically more general form. Okay. Now try to find out what are the intercepts made by this circle on the axis. So basically we are saying that this is my x-axis, this is my y-axis. Forgive my drawing please. This is your, sorry, I'll draw again. This is your circle. Okay, this is my y-axis, this is my circle. I want to find out this intercept and this intercept. What is the length of this intercept and this intercept? We'll start with this intercept on x-axis. Let us see where this circle intersects x-axis. For that we have to take the intersection of this circle with the line. Equation of x-axis is, what is the equation of x-axis? It is y is equal to 0. So I have to take the intersection of this circle star with this line y is equal to 0. So basically I'll put y is equal to 0 in star to obtain the points where the circle is intersecting x-axis. So I'll get ax square plus ay square, that will be 0, 2gx plus c is equal to 0. Now this is a quadratic equation. Let its roots be x1 and x2. Okay, then we know that sum of the roots, that is x1 plus x2, will be minus b, the coefficient of x, that is minus 2g upon coefficient of x square, and product of roots is, that is x1 x2 that is the coefficient of the constant, the last constant term, coefficient of x raised to power 0, that is c here, upon the coefficient of x square, that is a. Now I want to find out this distance. What is this? The roots are x1 and x2, so x1 will be the coordinate of this point, or x2. Suppose x1 is the coordinate of this point and x2 is the x coordinate of this point. This is suppose a1, this is a2. Then I want to find out a1, a2. I want to find out a1, a2. What will be that? That will be x2 minus x1. Now, what is x2 minus x1? I can write this thing as x1 plus x2 square minus 4x1 x2. Actually, I should write it like this. There can be a confusion. I should write a1 a2 as mod of x2 minus x1. I don't know which point is, if the roots are x1 and x2, I don't know whether this is x1 or this is x1. I don't know. So it is on the safer side that we compute a1 a2, because we are dealing with the length, that is modulus of x2 minus x1, and that is the positive square root of this thing, x1 plus x2 square minus 4 x1 x2. You must be able to note this thing. This is nothing but the algebraic formula. I can write this thing as x1 square plus x2 square plus 2x1 x2 minus 4x1 x2. That plus 2x1 x2 minus 4x1 x2 will give me minus 2x1 x2, and that will give me x1 square plus x2 square minus 2x1 x2. That will give me x1 minus x2 whole square, and the positive square root will give me this thing. Now what is this? This is equal to minus 2g upon a square minus 4c upon a. This is equal to 2 times g square minus ca upon a. Obviously a is not 0, otherwise this star is not a circle. If a is 0, then obviously this is not a circle, so a is not equal to 0. So this is the x-intercept which this circle star is making, right? Now we can make the cases when g square minus ca is greater than 0, then obviously we have a real intercept. It means that circle is actually making an intercept on x-axis, something like this, right? And if g square minus ca is equal to 0, it means that circle is touching x-axis. Okay, this point. And if g square minus c square ca, g square minus ca is less than 0, then it means that the roots x1 and x2 are imaginary, and in that case circle is not actually cutting x-axis. So this is the case, right? Now this was the intercept on x-axis. Similarly, we can find the intercept on y-axis. For that, we have to take the intersection of star with x is equal to 0. So you will obtain, I'll write down simple, instead of g square you'll have f square, and everything else will be same. Intercept on, this was the intercept on x-axis. Similarly, intercept on y-axis will be, intercept on y-axis will be 2 times f square minus ca upon